In the vast and silent expanse of the cosmic void, darkness reigns like an invisible monarch, quietly governing all that exists. Within this boundless emptiness, there resides a mysterious constant, unseen yet more impregnable than any fortress erected by human hands. This is no barrier forged from matter, but a law woven from the very fabric of reality itself. We call it the speed of light. The name evokes a sense of poetic lightness, yet it conceals an absolute authority. It stands as the supreme decree imposed by the universe upon all matter, energy, and information. Light is not merely the medium through which we behold the beauty of the stars or trace the boundaries between dawn and dusk. It is the heartbeat of space and time, the standard that dictates the manner in which the cosmos operates. From the tiniest subatomic particles to the colossal galaxies engaged in their eternal dance, everything submits to its rule. When we speak of light in a vacuum, we are addressing an extreme uniformity. Light always advances at the same velocity, unchanging and eternal. It matters not whether the source of emission is at rest or hurtling forward at astonishing speeds, nor does the state of the observer hold any relevance. This is a fact that upends human intuition. In our everyday world, velocities are relative. If you pursue a moving vehicle on foot, that vehicle appears to slow in relation to you. Light, however, defies this. Even if you chase it with the most advanced technology imaginable, it recedes from you at its original pace, indifferent and elusive. No object possessing mass, be it a minuscule speck of dust or a vast interstellar vessel, can ever match the speed of light. Even attaining 99% of that velocity leaves an insurmountable chasm, for as one draws nearer to the limit, the object's mass increases in a bizarre fashion, and the energy required escalates geometrically, approaching infinity. This is not a failing of propulsion systems or technological inadequacy, but a resolute denial inherent in space and time themselves. The universe seems equipped with a safeguard, barring all massive entities from encroaching upon that sacred threshold. This invariance renders light the greatest and most precise measure of the cosmos's immensity. We often hear that light can circumnavigate the Earth more than 7 times in a single second. Such velocity is staggering. Yet, in the grand ocean of the universe, it suddenly appears pitifully sluggish. A second's worth of light cannot even reach the moon. To arrive at the nearest star demands years, even millennia. Interstellar distances are so vast as to beggar comprehension, transforming light from an instantaneous courier into an aged herald bearing outdated missives. This yields a poetic yet chilling truth: when we gaze upon the night sky, we never witness the present. The nocturnal firmament is a colossal museum of the past, preserving images from epochs long gone. Consider the sunlight that warms your skin in the morning. That radiance departs from the sun's searing surface and arrives at you only after 8 minutes. Should the sun abruptly extinguish or vanish from existence, we would remain oblivious for those 8 minutes. Earth would still bask in its glow, plants would persist in photosynthesis, and humanity would carry on with ordinary lives, unaware that their life-giving source had perished. We forever inhabit a delayed rendition of cosmic reality. The greater the distance, the more ancient the past we perceive. The luminescence from distant galaxies, those faint specks captured by telescopes, may have embarked on its journey before humanity emerged on Earth, or even before the planet itself coalesced. They carry portraits of the universe's genesis, narrating tales of formation and destruction from millions or billions of years ago. Observing the heavens is akin to perusing a grand chronicle scripted in light, though its pages recount only what has already transpired. The galaxies twinkling tonight may, in their true present, have collided, fragmented, or been devoured by voracious black holes. Yet the tidings of their demise have not yet reached us. We are ensnared in a bubble of perception, where all information arrives tardily, and the universe now forever eludes our sight. If the speed of light were different or instantaneous, the entire edifice of reality would crumble and transform utterly. The physical laws we study, from the electromagnetic forces that bind atoms to the gravitational pull that sustains planets in orbit around stars, are finely tuned to this precise value. It is no arbitrary figure, but the cornerstone that prevents cosmic annihilation, the golden key to stability. Without this limit, causality would dissolve. Events might precede their causes, engendering illogical chaos. Time, unbound by the constraint of light speed, would forfeit its meaning. Thus, light serves as both a diligent messenger and a vigilant sentinel guarding the boundaries of reality, ensuring that all proceeds in coherent sequence. This absolute limit provokes profound philosophical and scientific questions in inquisitive minds. Why this particular number, and not another? Who or what established this boundary, and what does the universe shield from our interference? The finitude of light speed reveals time not as the uniform, absolute river we once presumed, but as something pliable, variable, and deeply personalized. Its flow accelerates or decelerates according to one's velocity through space and the gravitational fields encountered. This is among the most direct and eerie consequences of relativity, where the speed of light compels time to yield. The closer one approaches light's velocity, the slower one's clock ticks relative to the external world. Aboard a spacecraft traveling at ultra-high speeds, a second might equate to hours, years, or even centuries on Earth. This is no fanciful conjecture from science fiction, but a reality substantiated by countless precise experiments. Two individuals moving at differing velocities experience entirely distinct temporal flows. Time bends not due to motion per se, but because the universe must adjust your temporal scale to preserve light's invariance for both parties. Hence, time becomes a relative quantity. Under conditions nearing the speed of light, an astronaut venturing to a distant star and returning might perceive the journey as lasting mere years. Yet upon setting foot on Earth, he would be astounded to find centuries had elapsed. Loved ones, friends, and familiar civilizations reduced to dust. He has journeyed into Earth's future, at the cost of eternal separation from his homeland's temporal stream. Such time dilation manifests even in our daily existence, albeit infinitesimally. Atomic clocks aboard Global Positioning System satellites run faster than those on the ground, owing to their greater velocity and weaker gravitational influence. Were engineers not to correct this discrepancy daily, the system would falter within hours, yielding errors spanning dozens of kilometers. This attests that the universe harbors no universal chronometer. Every object, every person, possesses its own temporal rhythm, a unique cadence, distinct from others. Light is the sole measure, the sole constant. It contracts and distorts everything, including time and space, to enforce obedience. If the speed of light bore no limit, time would lose its structure of past, present, and future, with all instants collapsing into endless confusion. This boundary forges the causal framework, the foundation of all narratives and histories. Time dilation near light speed, and surpassing it would shatter reality's deepest order. Exceeding light is not merely accelerating further, it would invert the universe's mode of information propagation. All events must have causes preceding effects, the trigger pulled before the bullet fires, the seed sown before the tree grows. Light is the guardian of this golden rule. Should an object surpass light's velocity, it could theoretically overtake images from the past, dispatching information before events unfold. Effects preceding causes would precipitate a logical collapse in physics, temporal paradoxes. A superluminal signal might loop back to its own past, spawning irresolvable contradictory cycles. For instance, you could transmit a message to the past to prevent its own sending. Does the message then exist? The universe appears to forbid such irrational scenarios. As an object's energy nears infinity in attempting to breach light's barrier, space and time react violently, thwarting the transgression. The cosmos does not permit you to go faster. Instead, it nearly halts your time, infinitely augmenting mass, rendering further acceleration impossible. This limit ensures information propagates in coherent order. No message arrives before dispatch. Without this stringent safeguard, our observed world would brim with contradictions, and reality could not coalesce into a shared, singular narrative. Thus, light is not merely swift, it is the grand gatekeeper of the universe. It determines what can influence what, and the extent of that reach. Every civilization in the cosmos, no matter how advanced or transcendent their technology, must bow to this stern frontier. This is no shortfall of intellect or engineering, but a rule embedded in the universe's fabric since the Big Bang's inception. Humanity's challenge lies not in constructing mightier engines to batter down light's wall, but in discovering alternative paths that do not directly confront the limits of spacetime, more ingenious shortcuts. Acknowledging our inability to race light, human imagination turns to solutions rooted in the geometry of space. Rather than piercing space like an arrow, we envision bending space itself to abbreviate distances, akin to folding a sheet of paper so that distant points touch. This audacious notion leads to the concept of wormholes, hypothetical tunnels linking remote regions of spacetime. In theory, such a conduit would permit traversal from one point to another more swiftly than light in flat space, without violating local velocity limits. For within the tunnel, you do not outpace light, you merely tread a shorter route. Yet fabricating and sustaining a stable wormhole demands extreme conditions scarcely conceivable in the universe. Negative energy, an exotic substance unobserved in nature, may be pivotal in preventing the entrance from collapsing instantaneously. Recent theoretical explorations, drawing from quantum field theory, suggest that phenomena like the Casimir effect, where virtual particles induce negative energy densities between closely spaced plates, might offer a pathway. Though it remains profoundly speculative and far beyond current capabilities. Another captivating idea is the warp drive, where a spacecraft does not propel itself but contracts space ahead and expands it behind, akin to surfing a wave in the fabric of spacetime. In this model, the vessel remains stationary within its spatial bubble, while the bubble itself advances. Mathematically, light is not surpassed in any local region around the ship, yet the craft arrives at its destination faster than light would in undistorted space. However, the energy requisites for generating such a bubble for even a modest vessel might equate to the output of an entire star, or more. The universe seems to render these shortcuts nigh impossible, isolating civilizations in their respective oases. Or perhaps we have yet to decipher the rules correctly. Hidden equations may hold the key. What we deem limits today were once deemed inconceivable. Flight through the skies was a mad dream, conversing with someone on the opposite side of Earth was sorcery. The speed of light may be a formidable barrier, but to the universe's astute progeny, it might serve as a subtle invitation. It compels us to seek more refined, profound avenues rather than brute force. Every civilization faces this cosmic trial. Whether they accept it and stagnate, or navigate the interstices of physical laws to advance, shapes their destiny and survival. We may not yet be prepared to unlock this portal, insufficiently mature to wield the power of space-time manipulation. Or the universe patiently awaits our posing the right questions, our intellect sharpening to pierce light's veil. At that juncture, the earliest observers who gazed upon the night sky saw only twinkling points of ignorance, unaware they were specters from the cosmic dawn, emissaries from primordial eras. Only later did we comprehend that the finitude of light speed weaves the tapestry of time, averting the dispersal of instants into chaos, and permitting history to be inscribed and memories preserved, albeit at the price of interstellar solitude. Though the speed of light's limit closes doors to bodily ambitions, the boundless pliancy of human intellect permeates reality's deeper strata. Where classical physics dissipates like mist, we do not look upward but delve downward, probing the microscopic architecture of the tiniest particles in search of other egresses. Rather than challenging light's velocity, we harness the miracles of the quantum realm. There, in the subatomic domain teeming with probabilities and uncertainties, physicists confront phenomena that even the greatest minds of the 20th century decried as spooky action at a distance. Envision quantum entanglement, a linkage invisible yet stronger than any physical chain. Two photons or electrons, separated by billions of light-years, maintain instantaneous interaction. Alter the state of one, and the other responds forthwith, as if the immense gulf of space were negligible. No signal traverses, no temporal flow intervenes between events. It is as though space is illusory, and the particles remain a singular entity in higher dimensions beyond our ken. Though light's edict prohibits employing this for instantaneous information transfer, recent research including experiments demonstrating quantum links from Earth to satellites and even quantum teleportation of information, reaffirms that entanglement yields random outcomes, precluding usable communication. It fissures the wall of perception. It intimates that at the universe's most fundamental level, a profound unity transcends the superficial separations of galaxies and stars. Decoding these ethereal threads might one day erase the notion of distance altogether. Not by advancing faster, but by recognizing that all points in the cosmos have been interconnected since the primordial surge. As humanity's gaze returns from the microscopic to the cosmic grandeur, the speed of light manifests as a spatial impediment rather than a temporal curvature. Relativity teaches that time is no even, absolute stream for all, but an elastic flux, contracting and bending according to velocity and gravity. A spacecraft nearing light speed becomes a time machine to the future. For its crew, a voyage to the galactic core might span mere decades, a lifetime suffices. They dine, slumber, and labor at normal biological paces, beholding the universe's wonders. Yet upon returning to Earth, tens of thousands or millions of years may have passed. The civilization that dispatched them dust, continents reshaped, humanity evolved into other forms or extinct. Conquering light speed exacts a cruel toll. The traveler spans space, yet is severed from his kin's temporal flow, a spectral wanderer between eras, eternally youthful while his familiar world ages and perishes in an instant. Time dilation paints a poignant tableau of eternal solitude. Reaching the stars means severing all bonds with past and present. Light, as informant and stern warden of temporal order, forbids returning to yesterdays to amend errors, but generously proffers a one-way passage to unpredictable distant futures. In the absolute hush of vast space, where each cubic meter harbors but a few hydrogen atoms in rarefied density, human fancy is drawn to the dark behemoths forged by forces overwhelming light, black holes. At the event horizon's boundary, time appears utterly frozen to distant observers. A venturesome craft plunging toward them or would, in the eyes of those left behind, have its image linger eternally. Fading gradually, tinted red by gravitational redshift, it hangs as a perpetual monument on the abyss's brink, suspended in the moment preceding engulfment. Yet for those aboard, the plunge to the singularity transpires in finite time, rent asunder by immense tidal forces, where space and time compress to an infinitesimal point. In these most extreme locales, where conventional physics falters, humanity hopes to unearth the key to a theory of everything. Amid black hole chaos or the Big Bang's eruption, contemporary physics' two grand yet conflicting pillars, quantum mechanics and general relativity, might find common ground. Upon discovering a unified theory, we could manipulate spacetime in manners that today inhabit only the most extravagant dreams, birthing pocket universes, engendering independent spatial bubbles. Or extracting energy from the quantum vacuum, the infinite foundational vigor seething in every millimeter of reality. Until that day dawns, we remain children piecing together cosmic fragments. Gazing at the night sky is not merely an aesthetic indulgence in stellar splendor, but a confrontation with our humble station. The universe expands, its pace quickened by enigmatic dark energy. Distant galaxies recede from us faster than light, sequestering their secrets eternally in obscurity. Billions of years hence, the night sky will grow emptier, lonelier. Light from neighboring galaxies will fail to outweigh spatial inflation to our eyes. This imposes an invisible yet urgent imperative upon human civilization, to comprehend, explore, and extend outward before the window of opportunity seals shut under thermodynamics' inexorable laws. The race against light speed is no contest of motion, but of understanding. Each unraveled equation, each particle unearthed in accelerators, each gravitational wave recorded, constitutes a modest stride in broadening possibilities' frontiers. We erect colossal observatories on high mountain peaks where the air is thin and crystalline, launch exquisite space telescopes into orbit, capturing feeble photons that have wandered for 13 billion years. This endeavor satisfies not mere curiosity, but the survival instinct of a sentient species. We yearn to know whence we came, why we are here, and whether others gaze skyward posing identical queries. In a remote future, humanity might no longer be confined to these fragile biological forms. Our consciousness could migrate to sturdier substrates, silicon constructs or pure energy fields, enduring millennia of interstellar transit. Then, concepts of time and distance would be utterly redefined. We might become architects of stars, seeding life on barren worlds, disseminating intellect's spark across the galaxy. Yet regardless of form, the yearning to transcend limits, to grasp at light, will endure as humanity's core. In those days when our ancestors huddled in damp caverns, trembling before thunderous skies, they daubed eerie shapes on walls to explain the inexplicable. They fashioned deities to command storms, sun, and moon, seeking solace in nature's uncertainties. Then, night was foe, stars' cold eyes of supernatural judgment upon humankind. Only later did we realize that the courage to emerge from fear's cave and confront truth marked the grandest pivot. We understood thunder as atmospheric discharge, the sun as a titanic nuclear furnace. We are no slaves to fate, but explorers of reality. Knowledge does not rob the world of beauty, it renders it deeper, more sacred. We extend profound gratitude to those who devoted lifetimes to decoding light's language. Albert Einstein, who laid relativity's foundations, Stephen Hawking, who beheld light amid black hole darkness, and the thousands of physicists, astronomers, and mathematicians laboring quietly in contemporary laboratories. They sacrifice youth and vision, transforming humanity from dust to voyagers probing reality's structure. Their steadfast efforts and devotion leave eternal contributions to knowledge and society. They stand beside solitary telescopes on snow-clad summits, hearken daily to the universe's faint signals in subterranean labs, decipher arid numerals and equations, rescuing us from ignorance's gloom. May that fire of yearning never extinguish, even facing the cosmos's dreadful silence. Future generations shall inherit this torch, not to conquer nature with arrogance, but to integrate with the stars' grand symphony in humility and awe. Something swifter and more enduring than light exists, human empathy and imagination. Only it can transport us instantaneously to the universe's edge, warming quivering souls with the light of long-dead stars. In the fleeting instants of heartbeat and temporal flow, we awaken to the universe's resounding plenitude. When beholding a loved one's face under warm golden light, you see not their present, but them as they were a billionth of a second ago, the time light takes to reflect from face to retina. This delay is negligible at close quarters, yet becomes an impassable abyss when gazing afar. We are trapped in solitary nows, forever sundered from the instantaneous reality of surrounding entities by light's invisible wall. Imagine the solitary journey of a photon. Born in the nuclear forge of a star at the observable universe's edge, it collides for millennia inward to the surface, finally liberated into vast space. For the photon, time does not exist. Relativity decrees that at light speed, time halts. The instant of departure merges with arrival at our telescope. Yet to us, bound by linear time, that odyssey spans billions of years. We receive ancient dispatches, testaments from stars turned to dust or collapsed into black holes. Thus, the night sky is no static portrait of now, but a resplendent necropolis of the past. Spectral galaxies perform their final waltz. This awareness of light's lag imparts to humanity a melancholic yet poetic sorrow. It reminds us that all we behold is reminiscence. When astronomers train the James Webb Space Telescope upon the heaven's darkest patches, they conduct a grand archaeology, tracing time's chronicle backward. Peeling the universe's layers to its origins, seeking the era when first stars ignited. We crave to witness that primal light, the cosmic microwave background radiation, the Big Bang's afterglow, like an infant yearning for its mother's countenance. This is a desperate yet proud endeavor, an attempt to commune with the cosmos. Proving we are no accidental wanderers, but integral to the grand narrative commenced 13.8 billion years ago. Yet the universe comprises not only light, but darkness, and that darkness proliferates. Dark energy, the mysterious force rending space asunder, propels galaxies apart at escalating velocities. There exist cosmic regions whose light will never reach us, a cosmological event horizon, beyond which all information is eternally severed. We dwell in astronomy's golden age, when skies teem with stars and galaxies. But in the universe's protracted lifespan, this is but a transient flicker. Billions of years hence, our descendants, if they persist, will gaze upon a blackened void. Only our galaxy's aging stars remain. They shall peruse our records as myths, unverifiable legends of spiral galaxies and luminous nebulae. This prospect of eternal solitude impels humanity to explore ceaselessly. We construct subterranean colossal particle accelerators, hurling protons to near light speed in collisions that recreate primordial conditions. Seeking matter's fundamental shards, bosons, quarks, comprehending how mass arises, how all coheres without dispersing. Each collision is an effort to touch reality's core, glimpsing creation's blueprint before time's ink fades. In this quest for truth, we confront our own frailty. Bodies of water and carbon prove too delicate before space's rigors. Cosmic radiation, weightlessness, immense distances verge on insurmountable. Yet the intellect blazing in our billions of neurons yields not. We dream of unmanned probes, light sails propelled by lasers, encapsulating humanity's knowledge in chips dispatched to neighboring systems. Transferring consciousness to machines, unbound by cellular senescence, pondering for millennia across the galactic gulf. This is no pursuit of personal immortality, but a yearning for consciousness's endurance. Lest the universe become an empty chamber devoid of observers. No matter how far technology advances, humility before nature persists. As knowledge accrues, we diminish. Earth is a blue mote suspended in a sunbeam, a life oasis amid a cold, hostile cosmic sea. All history's kings, tyrants, saints, sinners have risen and fallen upon it. Our arrogant centrality crumbles before the stars' grand silence. In that self-dissolution, a new beauty germinates, the beauty of love and responsibility. We grasp that we alone safeguard this life. The sole bestowers of meaning in an indifferent cosmos. The race against light speed may ultimately signify not victory, but comprehension. Comprehending that we are the universe's means of knowing itself. When a child gazes at the plow, a poet composes odes to the moon, a scientist unveils new physical laws, the cosmos peers into a mirror and opens its eyes. We are matter's eyes, ears, heart. Our duty is to keep those eyes lucid, ears attuned, heart pulsing, even as expanding darkness and thermodynamic chill threaten to close life's portals. When dissecting atomic structures, we behold vast voids. Gazing to the universe's edge, we likewise behold vast voids. Between those infinities resides humanity, the bridge linking the infinitely small and infinitely large. We are woven from stardust, heavy elements forged in the flames of supernovae billions of years past. The iron in your blood, calcium in your bones, gold in your adornments, all legacies of perished stars. We are stars that think, matter that loves. This is a miracle of probability, never to be taken lightly. In those days when ancestors trembled in damp caverns, gazing fearfully at thunderous skies, they daubed walls with eerie forms to explain the inexplicable. They crafted deities to command storms, sun, and moon, seeking solace in nature's uncertainties. Then, night was foe, stars' cold eyes of supernatural judgment upon humankind. Only later did we realize that the courage to emerge from fear's cave and confront truth marked the grandest pivot. We understood thunder as atmospheric discharge, the sun as a titanic nuclear furnace. We are no slaves to fate, but explorers of reality. Knowledge does not rob the world of beauty, it renders it deeper, more sacred. We extend devout reverence and profound gratitude to the guardians of knowledge's beacon. Physicists, astronomers, mathematicians, quiet engineers, standing beside solitary telescopes on snow-clad summits, hearkening daily to the universe's faint signals in subterranean labs, deciphering arid numerals and equations, rescuing us from ignorance's gloom. They forego quotidian joys for humanity's glimmers of truth. Their steadfast efforts and devotion leave eternal contributions to knowledge and society. No matter how far humanity voyages, becoming interstellar travelers or integrating consciousness into vast computational networks, may we never lose that primal tremor before the night sky's beauty. retaining humility before the cosmos, wielding knowledge's power not to dominate or destroy, but to protect and nurture life. Disseminating human warmth to the galaxy's coldest reaches. Something swifter and more enduring than light exists, not hypothetical tachyons or spatial leaps, but human memory and love. Only it pierces all barriers of space-time, linking resonant souls. Even as the universe decays, existence's meaning resides wholly in moments cherished beneath the starry vault. To deepen our appreciation of the speed of light's significance, we may reflect upon its measurement history. As early as 1676, the Danish astronomer Ole Romer, through observations of Jupiter's moons undergoing eclipses, first estimated the speed at approximately 220,000 kilometers per second. This was a breakthrough, for prior beliefs held light to be instantaneous. Subsequently, in 1849, the French scientist Armand Fizeau employed a rotating toothed wheel apparatus for a terrestrial measurement, yielding 315,000 kilometers per second. More precise values emerged from later experiments, such as the Michelson-Morley endeavor, which not only confirmed light's invariance but also laid the groundwork for relativity. Today, we know the vacuum speed of light precisely as 299,792,458 meters per second, a value enshrined as the basis for international units of measurement. The speed of light plays a pivotal role in Einstein's renowned equation E equals mc squared. This equation discloses that energy E equals mass m multiplied by the speed of light c squared, signifying the interchangeability of mass and energy. A minuscule mass can convert into immense energy, as occurs in nuclear reactions. This elucidates why the Sun sustains its radiance for billions of years. It transmutes hydrogen mass into energy, illuminating the entire solar system. Concurrently, the equation implies why attaining light speed is impossible, requiring infinite energy to accelerate a massive object. The universe's expansion further underscores the speed of light's enigma. The Hubble constant, proposed by astronomer Edwin Hubble in 1929, describes the expansion rate. Current estimates, amid ongoing debates known as the Hubble tension, hover around 70 to 76.5 kilometers per second per megaparsec, implying distant galaxies recede from us, with velocity increasing with distance. This expansion, initiated by the Big Bang, accelerates due to dark energy, a mysterious force comprising approximately 68 to 70% of the universe's energy-matter density, acting like anti-gravity to propel galaxies asunder. Without it, the cosmos might have begun contracting. Meanwhile, dark matter, accounting for about 27%, plays an opposing role. It neither emits nor reflects light, yet influences visible matter gravitationally, preserving galactic integrity. Absent dark matter, galaxies would disintegrate from rotation. Scientists infer its presence via galactic rotation curves and gravitational lensing, though its nature remains enigmatic, possibly novel particles like weakly interacting massive particles. Quantum entanglement, while seeming to permit superluminal interplay, violates no causality. Entangled particle states correlate instantaneously, yet convey no information, as outcomes are random. This bolsters the speed of light as information's propagation limit. Recent advancements, such as demonstrating quantum teleportation and Earth-to-satellite links, underscore entanglement's potential for secure communication, without breaching relativity. Wormhole theory offers prospective shortcuts. Grounded in general relativity, wormholes resemble space-time tunnels connecting distant points. Traversing one could achieve effective superluminal travel without locally exceeding light. Yet sustaining them necessitates negative energy density, potentially realizable via quantum field theory's Casimir effect, though still highly theoretical. Black holes' event horizons are another wondrous boundary. Their escape velocity equals light speed, nothing crossing, including light, can return. The horizon's size depends on the black hole's mass. For one of solar mass, the diameter spans about 3 kilometers. Within, physics breaks down, perhaps concealing clues to unifying quantum gravity. Multiverse theory broadens our vista. Our universe may be but one bubble among myriad, each with variant physical constants. In eternal inflation models, new universes spawned ceaselessly from quantum fluctuations. This explains our cosmos's life-conducive parameters. A different speed of light elsewhere might preclude galaxy formation. Recent developments, including experiments probing photons' dual locales and supersymmetries ties to dark matter, fuel debates on the multiverse veracity. These strata of knowledge kindle boundless curiosity toward the cosmos. The speed of light is no mere numeral, but a key to deeper enigmas, beckoning us to explore without cease.